Alright, I'm solving rational equations, and this one has the fraction y over y plus 3 plus the fraction 2 over y squared plus 3y is equal to the fraction 6 over y. So we like to get rid of denominators, so the y plus 3 and the y are fine. I can go ahead and multiply by those, but let's just go ahead and rewrite it so we can make sure there's nothing hiding in that middle one since it is factorable. Lots of people will be able to look at that and just break it down and not have to rewrite it. But we're going to rewrite it, keep the first fraction y over y plus 3. The middle fraction 2 over y squared plus 3y, I'm going to pull a y out of the bottom. So that'll be y times y plus 3. And that'll be equal to 6y. And in that case, I can definitely see when I go to multiply by a common denominator or a common factor of those denominators, I need both a y and a y plus 3 to cancel them all out. Okay, so I'm going to multiply all three fractions by y times y plus 3. And the first fraction, it will cancel the y plus 3's out, so I have y times y. And the second fraction, it'll cancel everything out and just leave me the 2 in the top. And in the right hand side, the y's will cancel out, so the 6 will be there, and it'll be 6 times y plus 3. So if I clean that up, I'll have y squared plus 2 equals 6y plus 18. I'm going to pull all that to one side, y squared minus 6y minus 16, and now I have a quadratic equation to solve. So I turned my rational equation into a quadratic equation by eliminating the denominators. Let's factor this. You can go through your factoring methods that I've given you in the past, but here it'll be y minus 8 times y plus 2, I believe. So that gives me two answers, y equals 8 and y equals negative 2. We do need to make sure they do not cause problems in those denominators. Those denominators, after I factored, look like y plus 3 and y. 8 and negative 2 do not mess either one of those up and make them 0, so they both work. Both work. Thank you.